presentation and 5 minutes for Q&A. Before we start, I would like to check for participants' attendance. Can you please all raise your hand? Okay, thank you very much. So without further ado, I would like to call upon the first participant, presenter for this evening, that is Chan Huan Yang. The paper ID is 44. The title is Tech Analytics on Course Reviews from Coursera platform. So please, Mr. Chan.
Yeah. Can you guys listen to me? Hello?
Yes, we can hear you.
Yeah. Let me know if you guys can see my screen.
Currently, it's black. Okay. All right.
Okay. Can I start now?
Yes.
Okay. So, good afternoon, everyone. My name is Huan Yang. So, I'm here today to represent my team to talk to you about our project, which is the text analytic of course reviews on course data platform. Okay, nowadays we can access quality education and whenever and wherever we want, as long as we have access to a computer. We are now entering like a new era, which is the revolution of online learning. Okay, some of the best online learning platform includes Coursera, edX, and Udemy. Those online courses deliver a series of lessons through a web browser or mobile device, which are conveniently accessible by the internet users at any time, any place. Okay, there are many advantages to online education, but there are plenty of factors we have to consider before become an online student. It is always better for us to explore all the preferable courses before jumping into any decision. Choosing a course that is not appropriate for us can knock down our confidence, and most importantly, it will harm our potential and abilities. Hence, ratings and reviews are always the major consideration factor by online course seeker before they joining the course. However, it can be time consuming to read all the information, especially the course review. Okay, let me move on. Okay. So in this research work, our research question are how can the text analytic techniques such as the engram analysis, word cloud, and sentiment analysis be applied to improve the online course searching process? And also what insight can be obtained by using text analytic techniques such as the engram analysis, word cloud, and sentiment analysis? To answer all these research questions, our objective is to propose a text analytic pipeline that includes text screening, text lemmatization, sentiment analysis, text mining, and finally visualization that can help course seekers to gain a quick insight into the courses as well as enable them to make a quick comparison between multiple courses. For this project, we have created a text analytic pipeline in the Python Jupyter notebook that can help the course seeker to gain a quick insight into their shortlisted courses. Our research method covers these 6 steps. They are data collection, data preprocessing, exploratory data analysis, text preprocessing, text mining, and finally the sentiment analysis. I'm going to start with the data collection phase. The data set used in this work is freely available at the Kaggle. This data set has a total of 1.4 million student reviews on 604 different Coursera courses. However, we only selected 3 different Python-related courses for the study and demonstration of the text analytic pipeline. The first course we chosen is the Programming for Everybody, which is aimed to teach everyone the basic of programming computer using Python. The second course we choose is a Python data structure, which aim to introduce the core data structure of the Python programming language. And the third course is the introduction to data science in Python, which aim to introduce the learner the basic of the Python programming environment and also some of the Python fundamental programming technique. Now we have discussed the data collection phase. Let's move on to the data preprocessing phase. In this phase, data preprocessing and cleaning will perform to ensure the validity of the data. We have removed the duplicate reviews from the data set. Besides, we also remove those reviews with string length which is less than 3 characters from a data set. And finally, we use the package length ID to label the language used in the each review. Length ID actually is a Python package retained from 5 different sources, and it is able to recognize 97 major different languages. We only selected those English label reviews for our study. Okay. Next, I would like to move on to the EDA phase. In the exploratory data analysis stage, we analyze data set and summarize their main characteristics. We first took a look at the ratings given by students of each shortlisted course. From this figure, we can see that the Python data structure has the highest average rating, which is 4.85 per file among the 3 courses. We also found out that it seemed like the length of the review also tends to be higher when a lower rating 1 or 2 was given. It means that people tend to like more when it going to provide some low rating for the courses. Okay. Next is the text preprocessing step. We perform numerous steps to help us to put all the text on equal footing. For example, we do the lowercase tokenization, lowercase string, expanding the contraction, punctuation removal, lemmatization, and finally the stop word removal to make all the text become standardization. Yeah. And the next part of my presentation is about the text mining phase to identify the significant insight from the course review. Basic text analytic techniques such as word frequency or collocation have been applied. Identifying collocations and counting them as one word help us improve the granularity of the text, allow a better understanding of its semantic structure, and lead to a more accurate text mining result. For this research work, we apply bigram and trigram analysis on all 3 the shortlisted courses. This figure is the word cloud generated using ngram data. By looking at the bigram and trigram analysis, we can easily get some good insight from them. For example, the course 1, we can see that it's conducted by someone called Dr. Cha or Charles Severin. Is somehow a Python programming course and generally has positive review based on the word keyword like great course and good course. Okay, for course 2 is also taught by someone called Dr. Cha or Charles Severin. Same with course number 1 is somehow a Python data structure course and generally has a quite positive review too. As we can see, the good and the great text is appearing at there. And for the course 3 is somehow related to data science and Python based on the workload display here. Okay. After performing the basic text mining technique, we proceed to apply sentiment analysis to the course review. It will perform on the course review to help our course seekers to have a good insight into the possible positive and negative review of their shortlisted courses. There are many available packages in Python which use different methods to do the sentiment analysis. For this work, we use the weather and text block to analyze the polarity of our shortlisted courses. Both textbook and whether using rule-based sentiment analysis algorithm, and the polarity score is like something between -1 mean negative and +1. Okay, and then we move on to the okay next slide. Okay, we perform the sentiment polarity of the review of shortlisted courses using both table, and then we get the average polarity score of them. After obtain the polarity of each review, we label those polarity that score greater than 0 as positive review, lower than 0 as negative review. This figure is the angle analysis of all the 3 shortlisted courses negative review. Some interesting insight can be found in the negative review workload there. For example, for the course introduction to data science in Python, some review highlight that using an outdated version of Panda and assignment is very difficult. Okay. Okay, we have complete the research method. Now we bring us to our discussion and finding. In the evaluation part, the information was collected from the internet and course data itself to verify whether the engram or our word cloud are accurate and useful in representing the overall insight about the shortlisted courses. The summary of the evaluation is shown here. The evaluation result shows that our angle analysis performed quite well by scoring 52 per 60 in accuracy and 55 per 60 in usability respectively. However, there is some concern about repetitive or redundant information is generated from angle analysis. For example, the trigame data size Python and Python data size actually both is carry the same insight, just only different in their term sequence. Okay, the sentiment priority score generated using textbook and Water was evaluated by comparing them with the actual rating given by the previous student. As you can see from this figure, the overall sentiment priority score generated by textbook and Water averagely lower than the actual rating by about 0.8. Although the G error is around like 60%, however, the system still able to get the ranking right. Okay, the sentiment classification performance of the textbook and Water also was evaluated by comparing with the actual rating. For those actual rating with a value greater than 3, we label them as positive and vice versa. The model performance of textbook and Water was then evaluated using a conversion metric and classification report. The model has a high true positive rate of 97%, which indicated it performed well when coming to predict positive sentiment. However, it's quite poor when come to predict the negative sentiment, as a true negative rate is only like 46%. The major challenging issue in sentiments analysis is highly related to the correct interpretation of the context in which certain words are used. Both the textbook and the Water simply not, I think, advanced enough to successfully deal with the sarcasm or context or some of the discussion. We can have a look at the simple example review below, which is put out from our dataset. The review went through all the text preprocessing steps and had been reduced to easy cost complete they without much effort really get much teamwork. Both the textbook and Water label it as positive with a probability score of 0.17 and 0.44 respectively. The reason for it is the word easy, which is positive in the essence. However, in this particular case, it was used to express the student disappointment, and it is not a good thing for the student expectation. So in conclusion, I would like to point out that the proposal text analytic pipeline solution able to achieve our research objective is able to help the course seeker to get a quick insight, including the positive and the negative review into the courses, as well as enable them to make a quick comparison between the multiple courses. I think that's all I have to say. I would like to thank you. And yeah.
Okay, thank you very much to the presenter. Now I open up for any Q&A. Any question from the floor? You may raise your hand. Or maybe I can start. Okay, Mr. Chan, or I call you Huan Yang.
Yeah, either way.
Okay, so you are using the existing Python library, right? The text block and Vader. Any tuning that you apply to the existing library?
No, we are using all the default setting. What we do is we at the text preprocessing before put into the library. Yeah.
Only the text preprocessing. So the
Yeah.
ones that you presented in your preprocessing methodology, right?
Yeah.
Any additional training data that you put in, or only the ones that you put in your dataset?
We only use the data set from that Coursera review to come out the sentiment analysis and don't have any extra data set to train the positive and negative morality score. Yeah.
So the your experiment is basically the actual data set that you download from Kaggle, and then you pre-process and then feed to the existing text block and Vader.
Yeah.
Is it?
Yeah, correct.
All right. So in your opinion, which one perform better?
Let me have a look. If not mistaken, should be the weather performing better. In terms of the score is generated is quite similar with what the actual one.
Any explanation for that?
Because you can see the rating scale here, the orange color, is quite the 4.6 is actually is from the actual review. and this is the generated using the weather, the orange color. Yeah, the for the test plot, the rating score is generally lower, much lower than the actual rating.
Okay, thank you. So I think there's a question from Law. How did you change the actual rating numeric to sentiment class, positive and negative? Because the rating is 1 to 5, right, from the Kegel?
Yeah, we just adjusted for the Kegel one is the test plot and whether the scale is for -1 to 1. Yeah, so we just changed to something like 1 to 5. The middle point now instead of 0, now we come with something like -2.5. Yeah,
So basically from rating star 1 to 5, um, you split it to 1 and 2 is negative, four
yeah,
and five is positive. Is it something like that?
yeah, true, correct.
Okay, so the ones in the middle belongs
Uh,
to?
no, we using like proliferated mean like for example, if 0 mean should be 3 and not 2.5. Yeah, mean we just shift the goalpost only. The rating the is still like same. We
Oh,
are not.
meaning that
Yeah,
the rating does not also that's why you presented the last findings so the from your last slide saying that the star is 1 but then it is classified as positive, right?
one should be negative based on our
Should be lah.
scale. Yeah.
But then it labeled as positive from text block and radar kan?
Yeah, this one that's
Ah,
why because it incorrectly predicted, we can say.
okay. So any other questions from the floor?
Okay, I see a question here. What is the purpose? So
What is the purpose of the study?
our purpose is to create a pipeline that can help the course seeker by looking at our result. We can directly gain some insight. For example, who is teaching these courses, what is the positive review, what is the negative review. So actually from our result, we can see from here actually, somehow this, for example, this is one of our result. You can see from here what is the negative and positive review in a quick glance. For example, you can see the negative contains some uh, very bad course, spend a lot of time, outdated Panda version. Yeah, this is our objective. Mean by instead of we looking at instead of the course seeker have to read through all the review, now only looking through this work crowd, we can get everything useful insight we would like to know before we opt in for a course. Yeah.
Okay, thank you. So I think we can move to the second presenter. Thank you again, Mr. Chan.
Okay. Thank you. Okay. Yeah.
Okay. So our second presenter is Mr. Hassan Adamu, paper ID 43. The title is Text Analytics on Twitter Text-Based Public Sentiment for COVID-19 Vaccine, a Machine Learning Approach. So please welcome Mr. Hassan.
Yeah, can you hear me? Hello, can you hear me?
Yes, but I think you need to speak louder.
Oh. Can you hear me now?
Yeah. Okay.
Okay, okay.
You can share your
Uh,
screen.
okay. Let me try to share my screen. Can you see my screen now?
Okay, yes.
Uh, Can you see my full screen? Hello?
Yes, yes.
Oh,
Please
oh,
proceed.
can I? Oh, okay. Can I
Yes, you
start?
can. Yes, you
Oh,
can
oh,
start
oh,
now.
oh, oh,
Okay.
okay, okay, okay. Assalamu alaikum, everyone. My name is Hassan Adamu. I'm here to present our research. I'm representing my team. Here are my co-authors, and the title of our uh, research is Text Analytics on Twitter Text-Based Public Sentiment for COVID-19 Vaccine, a machine learning approach. Here is the presentation outline. I have about 6 items: introduction slash problem statement, mapping research questions and objectives, methodology, experimental analysis and discussion, conclusion slash recommendation, and references. Let's begin with the introduction. Uh, Text analytics. As you already know, text analytics is nothing but to mine text data and drive some insight, some information, or some quality information out of it. So, looking at this chart, there are so far in the world, that is as of last year, May 2020, there are about 4.66 billion active internet users around the globe. And also, there are about 4.28 updated unique mobile internet users, and there are about 4.14 active social media users around the globe, and there are about 4.08 active mobile social media users. This statistics was getting from the Statista infographic. And looking at the active social media around the globe, 4.14 billion, you can imagine how many, or what kind, or how many kind of the volume of the text deposited every second on the internet. So in this research, we choose Twitter because there are a lot of social media like Facebook, Instagram, and etc. So in this research, we choose Twitter to collect our data. So you can imagine how the kind of the text that is always depositing on the internet. And also internet, they have more than 400 active more than 400 million active users for Twitter. So that is why we choose Twitter as an object, or to collect our data. Then also we use sentiment analysis in this research to drive or to see the opinion or the sentiment of the people regarding what? Regarding COVID-19 vaccine. So this research is nothing but a sentiment analysis research to see the opinion and the sentiment of the people around the globe regarding COVID-19 vaccine. And in this research, we use the 3 most popular sentiment analysis object, that is positive, neutral, and negative. And also we apply a machine learning techniques, that is HBM and KNN, to classify and to predict the level of the sentiment of the people regarding the COVID-19 vaccine. If you go to the next slide, that is mapping research question and objectives. For the research questions, we have about 2 research questions, and how we are going to answer this research question. Then research objectives, we try to answer the research questions. Then the research question number 1 is, how can pre-processing of Twitter data and machine learning algorithm help in detecting public emotion, that is public sentiment, regarding COVID-19 vaccine? So research objective number 1 is we to collect the data from the Twitter regarding the COVID-19 vaccine. And also, after collecting the data, we clean the data sets by applying different pre-processing techniques such as stopword removal, hashtag removal, lemmatization, and etc. Then research question number 2 is nothing but the performance variation between the machine learning algorithm. After pre-processing of the data, how are we going to see the variation between the 2 machine learning algorithms, how well they classify the data? So we are going to evaluate and classify the sentiment analysis data using Cephalic vector machine and K-nearest neighbor. And the next thing is the methodology section. As we already know, that it's obvious that in a data mining research, there is a popular model, or there is a popular technique that we normally apply, that is CRISP-DM, cross industry process for data mining. And this CRISP-DM, we utilize it in our research. It has 6 stages. So in our data collection, we apply TweePy API to collect our data. So we focus on the sentiment analysis, I mean, the opinion of the people regarding COVID-19 vaccine. And also the programming, the research approach is of course qualitative because it's Twitter data or it's a text data. And also the programming language used in this research is Python. And the Python library, some of the Python libraries used in this research is NLTK library and scikit-learn library. And the continuation of the research methodology is, this is some of the sample of the Twitter data that has been collected regarding the COVID-19 vaccine. You can see that the raw data, we collected about 7,608 data. Then after cleaning, applying some pre-processing techniques, we remove all the duplicated tweet, and after the pre-processing, we drive, or we end up with 5,200 clean data set. So this is the data set description. The data is multivariate, missing values none, and the number of instances is 5,200. Number of attribute tree and data set data type is text, of course. And these are some of the flow of the model. I mean, right from the data set, cleaning the data set, feature engineering, and splitting the data set into two, training data and testing data. Then we apply all the machine learning algorithm and evaluate the data. I can elaborate more in the next subsequent slides. Then experimental analysis and discussion. So after leveling the data set, we find out that the positive sentiment is 31%, and also the neutral 47%, and the negative sentiment is 22%. Definitely, this data sets, there is a kind of imbalanced data set. So there is a technique that we apply, which I will show in the next slide. This is the word cloud. This word cloud will show how the people, I mean, their sentiment regarding the COVID-19 vaccine. You can see for the positive sentiment, you can see the most frequent word is effective, approve. Of course, all these words are a positive word. And we can see for the neutral word, like today, vaccination, we can classify them as a neutral comment. And for the negative comment, like emergency, death, all these most frequent words, we can classify them as negative comment. So this is automatically generated from the word cloud technique. The next thing is, yeah, like I said from the previous slide, that the data set was highly imbalanced. Yes, it was imbalanced. So we apply a technique called syntactic minority oversampling technique, that is SMART technique, at least to balance the data set. So after balancing the data set, we focus more on the accuracy for the evaluation metrics. So we focus on the accuracy metrics. So this is the formula of the accuracy metrics. So after passing the data set into the machine learning algorithm and split the data into 70-30, 70% for training and 30% for testing, the result that we get is that SBM, that is support vector machine, surpasses the KNN, that is K nearest neighbor, with 88% accuracy, and KNN with 78% accuracy. Then after that, I think that is all. Then this is the conclusion or / recommendation of this research. Yeah, of course, we can leverage and analyze emerging the public debate regarding COVID-19 vaccine. We can use machine learning algorithm to do that. And also capability to have real-time monitoring of public discussions for concern. And concern for public health and emergency planning. Then also this research can assist government and authorities in decision making regarding COVID-19 vaccine. I mean, example like the number of vaccine to produce and etc. And also we'll have the opportunity to educate public to increase vaccine uptake. Looking at the neutral part, so still there are many countries that are still don't want to take the vaccine because they are kind of afraid or something like that. So this research can also help the government to educate the public regarding the COVID-19 vaccine. And also in this research, the limitation, I mean, we focus more on the Twitter platform to collect the opinion of the people. So I think if we can collect more data from other sources like Facebook, Instagram, and WhatsApp, and also if the data is increased, the machine learning algorithm can be improved. I think that is all. This is the references, and thank you for listening. Yeah.
Okay, thank you very much. I open the question from the floor for Mr. Hassan. Okay, can you explain the technique used to balance the data, because you mentioned earlier, right? Imbalanced data. Can you clarify a bit on that part?
Yeah. Because the data set was imbalanced, so that is why we apply the technique. You can see the data set was imbalanced, so that is why we apply this MOTS, that is synthetic minority oversampling technique. This is just like an artificial a technique of balancing the data set. When you have an imbalanced data set, there are so many techniques that you can use to balance your data set. So I think, or we find out that synthetic minority oversampling technique is the best for our data. Yeah, it depends on the kind of the data that you have. If the data is highly imbalanced, then you can choose another technique. But for our research, the data set is unbalanced, of course, but synthetic minority oversampling technique is the best technique based on our research or to the base of our knowledge to apply to balance the data set. Yeah.
Okay, the second question. How do you pre-process the 7,000 data? The first that you downloaded, right? 7,000 something. So how does the filtering?
Okay. When we collected the data set, that is a 7,000 data set, what we do, we have to first pre-process the data manually first before putting into the Python library to apply different pre-processing techniques. So some of the things that we do, definitely while collecting the data, there must be some duplicated data. So this kind of duplicated data, we remove them manually. Then we apply so many pre-processing techniques. You can see the data cleaning. Under the data cleaning here, there are so many, this is just a few out of them. There are so many pre-processing techniques that we apply to clean the data. But to reduce the data seriously, we use we use it manually to reduce the data, because some of the data are not even uh, relevant, I mean, to the research. So some of them seriously we do it manually. Yeah.
Basically, when you say irrelevant, it's based on the justification of the researcher, is it?
Yeah.
Okay, actually, I'm interested on the first finding, on the neutral, because neutral is having the highest percentage, right?
Yes.
Okay, because I assume your experiment is basically referring to lexical analysis based on the words, right? The positive words, the negative word. So
Yeah.
I think basically when we talk about social data, they are much more to see. Okay, maybe can
Okay.
be improved by adding,
Yeah.
semantic or some other those things. So I think that also contribute to your findings.
Okay. Thank you
Yeah,
so much. Thank you so
right.
much for the contribution. Yeah. You're right. Okay.
Okay, so anything else from the floor for Mr. Hassan? Okay, if nothing, thank you very much again.
All right. Thank you so much.
All right.
Thank you, everyone.
Okay, we will proceed to our third presenter, Miss Kathleen Sui Nyotan, paper ID 42, a study on multi-word expression features in emotion detection on code mixed Twitter data. Kathleen, are you around?
Yeah, thank you, Dr. Suraya.
Okay.
Good afternoon. My name is
Sorry.
Kathleen Tan, and we are from Tuku Abdul Rahman University.
sorry, because I opened the wrong slide, the one with the recording. Yeah, so good afternoon. My name is Kathleen Tan, and the title of my paper is A Study on Multi-Word Expression Features in Emotion Detection of Code Mix Twitter Data. It has become quite a normal practice for us to express how we feel and what we think on social media platforms such as Twitter and Facebook.
Hi, Kathleen. Do you share your screen?
Oh, you can't see, is it?
Yeah, I cannot see your screen.
Sorry about that. Okay, can
Yes.
Yeah, sorry about that. Right, it has become a normal practice for us to share our thoughts and feelings on social media. And what happens is that this has created a large and abundant volume of data that is free, available. And this free and abundant data is actually a very valuable resource to companies and organizations because they can actually carry out emotion analysis on the text in order to gather insights that are useful for them to make better decisions. Now, in our study, emotion detection is defined as classifying the text in terms of the emotion labels, whether happy, angry, sad, and so on. And in multilingual countries, we typically use a mixture of languages in our conversations. In Malaysia, for example, you will notice that whenever we talk, whenever we write in our social media comments and posts, we use a mixture of Malay and English. And the term code mixed text refers to text that has a mixture of words from multiple languages. Now, very often when we write our sentences, they contain multi-word expressions. So a multi-word expression is when we have two or more words that we use together in order to express a specific meaning. Examples of English multi-word examples are racing circuit, take in vain, and a clean bill of health. Whereas examples of Malay multi-word examples are Peter Magnet, Kimia tak organik, and hukuman penjara seumur hidup. Now, commonly we use n-grams as features in natural language processing tasks. So what this means is that when we have a phrase such as feel like $1 million, perhaps after undergoing pre-processing whereby we remove stop words the phrase would then become feel like $1 million. And if we were generating n-grams from 1 to 3, it would actually produce unigrams, 4 unigrams feel like $1 million, bigrams feel like million and $1 million, and the trigrams feel like million and like $1 million. So what this means is that instead of considering the phrase feel like $1 million as a single term, as a single unit of expression, the use of n-grams would generate 9 different features as given in the example here. So overall, this will result in a very large feature set, which in turn will result in a longer training time for the model. And because multi-word expressions were not processed as a single unit, there is actually a loss of meaning. Like for example, if we say feel like or just $1 million alone, it doesn't convey the feeling of happiness or joy that the person was actually expressing. And we found that in literature, there have been suggestions that incorporating multi-word expressions identification can improve sentiment analysis. However, this has not been established yet. Therefore, the research question that we would like to address in this study is what is the impact of multi-word expression identification on the emotion detection of code mix Malay-English text? Our contribution are as follows. We introduce a method that uses Malay and English multi-word expression features to provide better semantic representation than n-grams in the emotion detection task. And we also assess the performance of Malay and English multi-word expression features on various supervised learning classifiers to perform emotion detection of code mix Malay-English Twitter data. The dataset that we use is a publicly available dataset called the Malaya dataset that has been labeled with 6 emotion labels as shown here. The emotions are anger, fear, happy, love, sadness, and surprise. And the steps that we carried out is to first construct a Malay-English multi-word expression lexicon by extracting the multi-word expressions from WordNet and WordNet Bahasa. So from WordNet, we obtain the English multi-word expressions, and from WordNet Bahasa, we obtain the Malay multi-word expressions. And then making use of the Malay-English multi-word expression lexicon, we carried out multi-word expression identification on the Twitter data. So what we did was this: we replaced each occurrence of multi-word expressions with the underscored version so that the multi-word expression can be treated as a single unit. And then after that, it went through pre-processing, TF-IDF vectorization for the SVM, MNB, and RF. And also we actually built the word embeddings in the LSTM models in order to produce the output of the emotion label. So for the experiments, the classifiers that were used were 4 very commonly used classifiers for emotion detection, namely support vector machine, multinomial naive Bayes, random forest, and long short-term memory. Now, for the feature sets for SVM, MNB, and RF, the feature sets used were TF-IDF with unigrams, TF-IDF with unigrams and bigrams, TF-IDF with unigrams, bigrams, and trigrams, and TF-IDF with multi-word expression features. For the LSTM, we actually made use of the basic architecture that consisted of embedding a word embedding layer that was trained on the dataset, and then after that 30 memory cells followed by a dense layer consisting of 6 neurons, and then after that with softmax activation. So the results are as shown here. What we find is that for SVM, the multi-word expression feature performed comparably lower, slightly lower than the unigram and unigram, bigram, and trigram features, but were comparable to the unigram features. For the multinomial naive Bayes, the performance of the multi-word expression was the best together with unigram, and outperforming the unigram plus bigram and unigram plus bigram plus trigram features. Same thing as the random forest. The behavior is actually the same for the multinomial naive Bayes. And for LSTM, we found that the multi-word expression features actually help to improve the performance of the classifier. So overall, we found that the results was not as different as we expected. This could be due to the insufficient coverage of the Malay multi-word expressions in the lexicon. And this can be inferred from the fact that when we compare the total multi-word expressions or the percentage of multi-word expressions, we found that for English, 43.6% of the lemmas were multi-word expressions, whereas for the Malaya, WordNet Bahasa, only 26% of the lemmas were multi-word expressions. In addition, the lexicon that we use only consisted of formal English and Malay multi-word expressions and did not include informal Malay multi-word expressions such as sedih juga and buat sakit hati that we found in the dataset. And in also the lexicon that was constructed and used in this study did not include code mix multi-word expressions such as tak bagi signal or happy gila. So in conclusion, we investigated the use of multi-word expression features in emotion detection of code mix Malay English Twitter data. For future work, there is a need to construct a multi-word expression lexicon that consists of informal Malay and English terms, as well as code mix multi-word expressions that we hope that can improve further the meaning of the phrases that are extracted and we hope that can also produce more accurate results and have better performance. Thank you.
Okay, thank you very much, Miss Kathleen.
Thank
So,
you.
any question from the floor? Okay, for your findings, right?
Mm-hmm.
The findings of the multi-word in Malay is very low, right?
Yes,
See
yes.
how many percent is that?
Let me present the screen to show. I think Malay was something like 26%.
Yeah.
Yeah.
So since it's quite low,
Yes.
it does contribute to the final result, right?
Yes, but not as what we expected, because we expected that it would make a greater difference.
Can you go back to the result
Result?
screen?
Yeah,
Yeah. So this one is you split the dataset English experiment and then Malay, right? You did
no,
not.
no, it's all code mix data. So
Okay.
yeah, I forgot to mention that for the SVM, multinomial naive Bayes and random forest, I carried out stratified five-fold cross validation. For LSTM, the split was 80% training and then 20% test set. That is the split ratio for the SVM, for the five-fold cross validation. Yeah,
Okay. So basically, this is a mix Malay and English, and then referring to the word net from both, right?
correct.
Quite high, oh, the accuracy.
Yeah, that's why.
Huh.
I think it has to do with the fact that there's a lot of data,
Okay.
157,740, and also perhaps the tweets that were gathered were maybe quite standardized in the way that the emotions were expressed.
I think it's being, it has all the data set also has all the emotion lexical so that it's easier for the
Yeah,
classification.
yeah,
Right.
probably. Yeah, in order to test it out more reliably, then I
Um,
have gathered my own data set, but I haven't got around to labeling it yet because it's very
mhm.
resource intensive to label.
Yeah, because if you
Yeah.
get the result that high, huh?
Yeah.
Right. I think also when you presented the result with
Mhm.
can you go back?
Yeah.
Uh,
Except for the multinomial naive Bayes, but the rest, yes, it was very high. I was quite surprised
yeah,
because
SVM and LSTM.
yeah,
Almost perfect.
yeah.
Ah,
Yeah, but then I think we have to validate this against the data
yeah, I
that we have
think.
collected definitely. But this was
Ah,
just a
and
preliminary.
also if you see,
Uh-huh.
there's not much different of unigram and even multi-word,
Yes.
98%,
Yes,
and
correct.
yeah. So
Yes.
that's why my I did say that is
Mm.
it due to the word net not sufficient enough? Uh,
Okay, okay. Yeah.
uh, kan?
True, true. Yeah, yeah.
So any other uh I think it's for further investigation
Yeah,
because
yeah, definitely.
for further investigation because if you present the result it should be, you need to justify why unigram and
Mm.
also multi-word have the same result. And it's almost perfect for SVM and LSTM.
Yeah. Thank you very much,
Yeah.
for highlighting that.
Okay. So any comments, any questions from the floor for our Miss Kathy?
Um, Hi, Miss Kathleen, Mazlina here.
Hi,
Can I
Masli.
see your result again?
Sure.
Because if I'm not mistaken, you say that for SVM, MNB, NRF, you use K-fold, right? Five-fold.
Correct.
And for the LSTM, you just use 20% testing. You separate the data into 80% training and 20% testing,
Correct.
right?
Yes.
And but you compare the performance of these four machine learnings.
Mm-hmm.
I think that's something not right there, because if you want to compare, you have to use the same cross validations. Then it will be more fair lah.
Yeah, true. But because of yeah, I actually followed one of the papers whereby they justified it by saying that the cost of training would be too high for the LSTM if we were to do K1 cross validation, and because for LSTM it goes through, I think, 30 epochs. So yeah, so
But
yeah.
it's not for
But
me.
it's what you have mentioned, yeah, it will be even more fair comparison if
Yes,
everything is using fivefold cross validation.
yes, for all. I
Yes.
suppose, because can when we do five folds, actually we separate the data into five groups, right? And then we take four for training, one for test, and we repeat the process. And finally, we average everything. So if we just for LSTM, if we just put aside 20%, we don't know what 20% data.
True.
Yeah, so it's unfair for my. That's my comments lah.
Yeah, thank you. Yeah, because it doesn't have the
Nice,
same
nice.
set of coupling of through the 5 different data
Yep,
sets.
yep. All right. Thank you, Miss Kathleen.
Yes, thank
All
you.
right, that's all lah.
Thank you.
Okay, thank you, Dr. Mazlina, for the good point there. Any other? Any other questions from the floor? So if not, I think thank you very much,
Thank you very much.
Miss Kathleen.
Thank you very much.
Okay, so we have our last presenter, Dr. Su C. Chai, paper ID 50, Incorporating Unstructured Text in Multi-Layer Perceptron MLP Network, Factors Affecting Partner Selection in Pair Programming. So I'd like to welcome Dr. Su.
Hi, hello everyone. Let me share my screen first. Share. Can you see the slide?
Yes, you can share your screen,
Okay.
your PowerPoint.
Oops, I thought I share my.
Yeah, your screen, but not your PowerPoint. Yes.
Let me see.
You just click the PowerPoint for us to see.
This one?
Yes.
Okay.
Yes. Okay.
Okay. So let me start now. Okay. So this is a research. Okay. So what we are trying to do now is that we are trying to for our the paper. This is paper 50. Okay. So the title of the paper is Incorporating Unstructured Text in Multi-Layer Perceptron MLP Network. What we are looking for is the factor affecting partner selection in pair programming. Okay. So first of all, let me explain what is pair programming. Okay, in a pair programming, like the word pair, it basically means two person. Okay, so one person will actually act as a driver, while another person is acting as a navigator. The driver is actually the one who is going to control the keyboard and also the mouse, while the navigator is the one looking at the design and development. Okay, in the pair programming process, okay, throughout the process, in between the process, these two roles, they are going to exchange their roles. Okay, so pair programming actually have shown a very good result in industry. And then in academic field, a lot of lecturers actually brought in this practice for the students to learn programming. Okay, what happened to this pair programming is that if the lecturer want to do pair programming, they are going to measure the students according to what they think they should match. Okay, either through the skills that they perceive, okay, how the lecturer sees them, or through the grade. Okay, if A should be paid with an A student, okay, B with a B student, and so on. Okay, so this is how this pairing work. Okay, it's actually by the perception of the lecturer. And we have to understand one thing is that for this pair programming to work, it actually depends on the partner. Okay, if you have a very bad experience for pair programming, it actually will result in students not willing to continue with this practice anymore. Okay. So for us in our research, okay, we are trying to see, okay, if the students are given freedom, okay, if students are given freedom to choose their own partner, okay, which is lacking in the research, what are the students going to look into when they are finding their partners? Okay, what attribute actually the students are looking into when they want to find their partners? Okay, what the attributes that the students are looking into, and unstructured text in the questionnaire affect the final accuracy of the predictions. Because when we do our testing, we actually give a questionnaire to the students, and the students are actually allowed to enter free text. Okay, so we are going to see whether this free text actually will influence the final predictions. Okay, so what we did was that we have a workshop, okay, for 5 days. Okay, I think this is not 2006, this was 2016. Okay, a typo there. 2016, 24th October to 28th October. It was actually a semester break. Okay, so every day we have it for 2 hours. Okay, so we give it to the first semester students from the Faculty of Computer Science and Information Technology from UNIMAS. Okay, so the course is actually an introductory course, the introduction to programming, which all the students in the faculty need to undertake. Okay, so at the end, we actually have 76 students who participate. Okay, so during the last day, we actually do the testing, and we give a questionnaire. Okay, so every day during the lecture plus lab session, the students are actually given lecture, which they will give introduce to the concept of programming. Then after that, they are going to do they were given question to do their practical, the programming part. Okay, so one point to remember is that the student actually already taken half of the semester course on this for this course. Means that for this 5 day, it looks like a revision for them. Okay, so students are participating with volunteer intention. Okay, means that we don't force them. They want to join, they join. Okay, for the 1 week. Okay, so during the last day, what they were told that on the last day they will be given a test. Okay, which the marks is not going to be calculated for the final grade for the course. Okay, so on the last day when they come, okay, they will explain for the first 30 minutes. The student will explain on this pair programming concept. Okay, so and then they will also know that they are going to choose a pair, and then they are going to change their roles after 15 minutes. Okay, the total duration for the question is actually 30 minutes. Okay, so the first 15 minutes, one person is going to take the role of driver, and then the last 15 minutes, then after that, they are going to change their role for the last 15 minutes. Okay, then after that, the lecturer is going to give them the solution for the problem, explain to them, and then give them the questionnaire. Okay, so after they fill in the questionnaire, then we do the other part. Okay, so in the first part of the methodology, what we do is that we input all this data on the age, on the ethnics, on the nationality, gender, their perceived skill, how they think about their skill of programming. Okay, their programming length, how long have they have been programming. Okay, so their partners, whether how they choose their partner, whether it's on ethnics, whether they're on gender, skill, whether they choose their friends, whether they choose them because of compatibility, whether they choose someone else besides them, okay, or they choose anyone. Okay, so they are given a questionnaire on this, and we enter into the data into our model. Okay, we do a feature selections and then we input this into the MLP model, and we check whether the output is actually their preference, whether they want to do pair programming or they don't want. Okay. So in the second part of our work, we actually incorporate text mining in this. Okay. So for this text mining part, we actually do data cleaning, okay, and then for data parsing and transformation, and next it go through the same process like in the first stage where we do feature selection, the MLP model, and the preference of yes and no on pair programming. Okay. Here it shows the result, okay? So you can see that in the first experiment, we actually have 76 participants, okay? And then we actually allocate 60% for training, 30% for validation, and another 10% for testing, okay? You can see that here our accuracy misclassification rate is 0.125, and then the features that were selected were actually age, gentle, ethnicity, and selecting partner based on comparability. Okay, that was the feature selected for our MLP. Okay, for in the second part, while we incorporate text minings, okay, so you can see that the kept terms we obtain is actually ideas, something related to ideas, discuss, share, opinions, help, partner together. Okay, this is the frequencies that we get. Okay, and the features we get is actually race, okay, ethnics, okay, their own ethnics actually, okay, choosing a partner based on the skill, ethnicity of the partner, and the topic of ideas means that the unstructured text that they enter, which is related to ideas, okay. So what is lacking in here is that while we are doing text mining, not all the students actually enter their comments in the questionnaire. Okay, we actually only receive 31 students who actually enter text. Okay, so our sample is not large. We only have 31 samples for this part. Okay, and then the MLP actually during the testing there was no misclassification rate. Okay, to compare this with our MLP, because in the first stage, the MLP actually have 76 samples. Okay, so because of these 31 samples who enter the structured text, okay, so we do again, we redo the MLP part without this text mining. Okay, and we get that the feature selection is actually ethnics, the programming length of the students, and then choosing a partner based on the race. Okay, so that is the feature chosen. Okay, so again, with MLP, without text mining, we actually we also get no misclassification rate. Okay, what we see is that incorporating text mining in this context does not improve the accuracy of prediction. With the limitation in our study is that there is only 31 samples we received with unstructured text. Okay, when freedom of partner selection is given to the participants in pair programming practice, the preference of the participants on whether they would prefer to do pair programming or not in the context of Malaysia depends actually on the ethnicity. Okay, means that you can see that from these three parts of the experiment, ethnicity is actually selected in all the model that we have. Okay, so but we conclude that further analysis should be done on the prediction capability with text mining with more data. Okay, that is the limitation of this study. Okay.
Okay, thank you very much. Any question from the floor? Dr. Su, basically,
Yep.
can you share again your screen?
Yes.
On your findings, right?
On the?
Okay, on the findings from this experiment, right?
Yes.
So basically, the student will fill in the questionnaire.
Yes.
In order for them to choose their partner in the class, is it?
They will fill in the questionnaire. Every student will need to do to fill in the questionnaire before they leave the class actually.
Okay. So your finding is that can we see the result?
Yeah, here. Yeah, this is with the 76, the total students. Okay, and you can see that the misclassification is actually 0.125. Okay, in the second part here, where we have text mining incorporate in the model, we only have 31 samples. Okay, and then with this one, we actually don't have any misclassification rate. Okay, same with the next texting, which there's no text mining incorporate, just the MLP with 31 sample.
Okay, so basically when they choose the partner based on race, based on ethnic, do they write it in the questionnaire or it's merely a selection?
It's a selection. It's a selection
Boolean.
in the questionnaire.
Okay, so which part do it's open text?
The open text is actually the comment about the comments that they enter. We have a section on open question on the comment.
So the comment, any findings from the comment?
From here, these are the terms that we actually get mostly, like pair programming actually create more ideas. Okay, so they can discuss, or something related to discuss, okay, something related to share, something related to opinions, something related to help, something related to partner, and something related to the word together.
Okay. So the findings, what is the future plan for them?
We actually things. Yeah, there are a few things that we think need to do. One is there should be more samples so that we know that whether the comment that they enter actually influence, actually give influence to the final predictions of the model. That is one part. Another part is that we also feel that we actually need to know. Let's say you give them the freedom to choose their partner. What is actually the result? Are they going to get a good result in programming or not?
So that's why, because the findings now is only the clear is from the ethnic, the race, and then the ones that they are familiar with. That is a common thing that we know, right? So since the data is very small, if you see the frequency also is like 9. So the total sample is 76, is it?
The total sample is 76 because it's actually a workshop where we are going to do revision, and then it's semester break where students actually some of the students actually went back to their hometown already. Yeah, but during questionnaire, it is very common. Participants do not want to fill on the comments part.
So that's why. So the feature selected here is basically a very common, it's on the age of the way they choose. So unless we feed with many text data, so we can say that it complement or it can contribute to result to the model that you develop.
Yes. A larger sample is actually a need in this one.
That's not much text to be processed here.
Yeah, it's not many when it comes to questionnaire with open question.
So there's one question. Can you show which the kind of data, so that is why you use in-text mining approach? So it's questionnaire, right?
It's a questionnaire. Yes, it's a questionnaire.
Questionnaire, and then you convert it male, female, and then the numeric and the open text is only the comment. Okay. So I think the room for improvement, is it significant, the result that you the findings?
for us, the main things that we see is that actually when we do the practice is that you basically can see how students actually approach their partner. They either will choose same gender, okay, or are their friends. We're actually predicting that gender will be a main factor. Okay, because you actually can see that normally when you ask the student to choose their partner or group member, they are going to choose according to gender. If they are in first year, I mean, if they are in first year, they normally will choose same gender.
So that's why I highlighted earlier. That is the
So
common
we are trying
features,
to say,
right?
yes. So, but the thing is, you basically can see that from this, gender is actually not the main criteria, but actually, the ethnics is the main criteria that the students are looking into. I think there is a
Ethnic is a
message
selection
behind.
also.
Sorry. Gender is
ethnic
also a selection. Yes.
selected also.
Gender of the partner is also a selection for them. You can see that basically the students are not looking at this, which we thought that gender is actually a criteria, but actually it's not. The students are looking at the ethnics of the partners.
Okay. So any other questions from the floor? Okay. I think it can be further investigated if more data.
Yes.
If more, maybe can try for next semester compilation of few semesters so we can see some patterns. Because now it's too small to verify and
yes, it's too
validate
small.
the
Yes.
things. Yeah, it's very small.
Yeah.
So anything from the floor? So Ms. Nadira asked for those with particular key terms are paired together. So that's why I say, so at the end of the day, from the findings, do they get paired? Or what is
we do give them a token of appreciation. We actually give them $5, ringgit Malaysia, not $5, ringgit Malaysia.
No. What Ms. Nadira meant, I mean, from your findings, right? Those with similar key terms, meaning that the ones that chose ethnic, the ones that chose gender, are they paired together in the class doing the pair programming?
Yeah. They actually choose their partner according to the ethnics.
I see.
Although from the eyes of us as a lecturer, when we see is that we thought that they choose according to gender. That's what we were thinking it should be gender. But what we get out is actually different. Actually not gender that they are looking for. They are actually looking for the ethnics of the partner. That is the interesting part that there are things actually at the back lah. Means that although we are Malaysia and Hari Merdeka, okay, so when they choose their partner, they actually look at the ethnics of the partners, which is a main criteria when they choose their partner.
Okay, I think more samples should be investigated.
Yeah. We agree that. We agree.
Maybe because mainly it's one class and then one subject and then from one university. So maybe if we have cross university, maybe we can have different result, different insight from different
maybe.
Okay, so I think that's all. Our last presenter. Thank you very much for the interesting topic. So Miss Nadira, now, okay, you can unshare your screen. So again, okay, so again, on behalf of the committee, thank you very much to all the presenter. All the topic is very, very interesting. So I think we can proceed for group photo, kan, Miss Nadira? Okay, can I request for all the participants to on your camera? So Miss Nadira, tolong ambil gambar kan? Alright. So there will be a timer. Is that all? Okay. So smile lah. 1, 2, 3. Okay, so again. 1, 2, 3. Okay, thank you very much, everyone. Hope you enjoyed the conference. Okay, see you again next time. Bye. Assalamualaikum.